So to recap, the idea of being a first-class data type is that you can do the same general types, categories of operations as you could with numbers or strings. So we saw that you could assign functions to variables, just like you can with numbers or strings. You can put functions into arrays or other data structures, just as you can with numbers and strings. You can pass functions into functions, just as you can with numbers and strings. And you can return functions out from functions as their return value, just as you can with numbers and strings. And now I want to make the point that you can create functions without assigning them to variable names, just as you can with numbers and strings. These are known as anonymous functions. Then we'll have one more point that we'll discuss in the final section. So here's a minor variation of an example we gave when we covered conditionals. It just flips a coin. So it computes math.random. If it's less than 0.5, it returns heads. Otherwise, it returns tails. And so if I run that, flip coin, if I trust the random number generator in JavaScript, about half the time I should get tails and about half the time I should get heads. All right, there was nothing wrong with this, but there was no reason we had to assign math.random to a variable first. Much more natural is to just put math.random here and never assign it to a variable. And of course, I get the same result. This is what we showed earlier. So with numbers, you can use numbers without assigning them to variables first. You can do the same thing with functions. So I can say, instead of square, I can say var f equals an anonymous function that takes x as an argument and returns, say, x plus 7. I didn't create a function named plus 7 first. I did it directly. F of 10 should give me 17. But still, I used a variable. I made an anonymous function assigned to a variable, but I can just call the anonymous function directly. I can say function, and so the parser isn't confused, I'll close that whole thing in parentheses. Take that anonymous function and call it on 10. And I get 17, same as before. So let's go back and revisit the random funct function. Well, this design is really a little bit deficient because it assumes that you've previously defined a function called square and double. It's not self-contained. If you don't define those functions first, this won't work. So much more natural would be to define the functions right inside the return statement. Function of x that returns x times x, curly brace, and a function that takes x or something, any name as an argument, and returns x times 2. So now it's self-contained. And so I made a function that squares a number, but I never assigned it to a variable name. I don't need to. Just like I didn't have to assign math.random to a variable name. I just create an anonymous function, unnamed, and I return it. And let's do the same. Oops. Run this thing, not math.random, and do the same thing as before. Var f equals random funct. And I don't know which of the two functions f is until I call it to see. F of 10, am I going to get 20 or 100? I don't know. Let's find out. I got 20, but now it continues to be 20. All right, so this was a much better approach. The previous approach assumed you had to define square and double first. It's much more natural to return the function directly, so the random funct method is self-contained. So it returns a function, but an unnamed function, an anonymous function. You need to know its behavior, but you don't need to know its name.